Okay, you can continue. And I think today you need to hand in programming assignment number 1. And actually the due date is set to the midnight. So at least you need to submit your programming assignment results of programming assignment before midnight. All right. Actually midnight of tomorrow, but actually you need to know that do not delay, or otherwise I may have a discount for the grades for you. So keep in mind. All right, so this is the submission of your programming assignment. Don't forget these, at least before midnight. Okay, so let me check. All right, I think if you don't finish, later you can try to use the picture to get this done. And right now, let us get back to the discussion for the results here. Confidence interval. Last week, we have this example. I think maybe you need to calculate. However, I already have the result directly, so I think at least you need to practice. This example says we have the observations from 1.2 to 1.09. All right, so for the 10 values, you need to predict. Can you have a mean? And can you have a sample variance? All right, so for this, I think you need to practice. If you have it, and then you can have this formula to calculate the confidence interval. Mean, sample mean, okay, plus and or minus. And this t need to be looked up. All right, and last week we already have the table to look up. As for the remaining, you see, sample variance. Sorry, actually, this is a sample variance. Is correct. Sample variance and over the sample size. All right, so this is a way. This is a way to have the confidence interval. All right, so this one through table lookup, you have the value t here. As for value t, what is the formula? 9 actually equal to 10 minus 1, right? 10 minus 1. Percentage, this is 90%. So why we have the value here? In fact, n minus 1 here. And next one, it is if we have 90% here, right? All right, so 90% you will have alpha. Alpha means 1 minus this one. You have the value here. So we have alpha over 2. So this one, you will have the value. That's why we have 0.95. Okay, so look at this. All right, so we have a percentage equal to 90, right? So that says 1 minus alpha equal to 0.9. That's why we have this. All right, so it says you have this first. All right, but I already have this one directly. So the same. That's we have the lookup directly. But right now, I just ask you to notice the two parameters, n minus 1 and 1 minus alpha over 2. If you have the parameters, I mean, you have the value for the two parameters, then you can look up. And through lookup, we have the value 1.933. All right, so you can recheck the table and then you have the value. Once you have all the value, then you can have the confidence interval, right? This is the confidence interval for this example, and we base on normal. We base on normal to have estimation of the confidence interval. Well, in the following, we try to generate the values so that we have the observations. How many? 500. With the 500, and then we want to check the coverage. How to have the coverage? If we have the confidence interval, and then we count 500 and how many fall within these. All right, so maybe these. Okay, and use these, then we can have the calculation of coverage. And right now we try normal. And also we try exponential, chi-square. So how to have this distribution? I think you can easily to have the formula in chapter 6. And right now, I just let you know, we have these. Normal exponential, chi-square, log normal, and hyper-exponential. And you can look up the table as well, and so that you can have the first definition. For the detailed definition, you can look up chapter 6. For chapter 6, I think you can have the formula for normal, exponential, chi-square, log normal. So hyper-exponential, you can have this definition in the context of chapter 6 as well. Why we want to have the distribution? Because how to have a confidence interval based on normal. And right now, if we construct 90% confidence interval, all right. So once we construct 90% confidence interval, we can try to use sample size 5 to construct these 10, 20, and 40. All right, so look at these 90%. Estimated by actually the confidence interval constructed by normal. So that'll check normal first. 90%. So how about the coverage? Approximately 90, but not exactly. Approximately 90, not exactly the same. However, you can look at these. If you have 40, well, almost 90, right? Why? Because for these, in fact, if we have a really large sample size, then we will have really good really good results. All right, but at this, normal, almost near the original expectation, 90%, right? So even we have 0.91, 0.90, 0.89, all right, and 0.90, almost 90, all right? However, if here about skewness, in chapter 6, we will have the definition. In fact, this one, symmetric or not. Zero, symmetric. Non-zero, then we have the asymmetric distribution. So for these asymmetric, right? And asymmetric, if we have a larger value that says, for example, here, asymmetric, and this is a symmetric one, normal, right? And all these one positive value. So this is the shape, possible shape of these. Okay, for example, this one exponential. If we have a large skewness, you see, how about the coverage? Really lower. Just want to let you know if it is not normal, because normal, it is a symmetric distribution. If we don't have the symmetric distribution, for example, here we have all positive skewness. The larger the skewness, and then the smaller the coverage, right? All right, so I think you can have these and all of these. And furthermore, look at these. Because of skewness, so we don't have the proper coverage, and shows the reduction of the coverage, right? And if we have a large sample size, how about this? You see, still can have the confidence, right? I mean, coverage equal to the confidence, near the confidence, unless this one hyper-exponential, because it has the large, really large skewness. So checking this one, it says confidence interval serving as the reference. It doesn't mean this one always valid for all the distribution, right? Of course, this one fitted the best for the original distribution, normal. However, for the others, serve as the reference. All right, so this table just want to let you know if you construct a confidence interval. It doesn't mean this is the exact confidence interval, but serving as a reference interval. Perhaps the values fall within the interval with the corresponding percentage of confidence. All right, I think you can have the observation from this table, and I think you can have the other discussion from the description of the task book. All right, so this is a discussion for the first one, confidence interval. Up to now, any question? If no, next one, we will have the preparation for hypothesis. Okay, hypothesis test. Well, we need to have the hypothesis test. Right now, think about you have the unknown distribution, and we want to know the mean. If we have some way to have the mean, and then we want to check, should we accept the mean or should we reject the mean? If you do something like this, such an action, it is called hypothesis test. All right, so for hypothesis test, we will have the following two values. One called null hypothesis, and the other one actually alternative hypothesis. If we have the two, of course we prefer this one, but sometimes we reject this and accept this. All right, so in fact, we have two choices, and we want to make sure through the hypothesis test to check, we need to accept H null or to reject H null. To reject H null, it says you need to accept H1. Well, if you have these, actually, for the hypothesis test, we will have the following errors. What that means, even you reject H null, but it is true, so you reject it, it is an error. And next one, you cannot accept H null, but you accept that one. All right. That says failure to reject. These are two possible errors. Let me repeat these again. Type 1 error and type 2 error. Type 1 error, it is true. H now is true, but you reject. And you can have this possible probability. And the next one, you need to reject, but you accept, right? False, you need to reject, but you accept. So this is the second type of error. And you may have the corresponding probability denoted by alpha and beta. All right, but right now we don't want to have the further discussion about the alpha and beta. All right, so you have these. H now actually is true, but you reject, so set it to alpha. And this one, it is false, but you accept. All right, so alpha and beta. If you want to have the other probability, actually, this one, true, so same, but we have two situations, right? So that's why you have 1 minus alpha. This one, you have 1 minus beta. I think you can use the table and so that you will know where to have this. It doesn't mean you have this one. No. All right, so here. Because true and then always true, but we have two cases, case 1 and case 2. Same, case 1 and case 2. But for the two cases, actually you have the O probability. So sum of the two probabilities should be 1. All right, so this is a notation, but we don't want to check it further. And right now, we want to let you know how to have the hypothesis test. Hypothesis test, maybe you think similar to confidence interval, but not the same. It is a different story. However, we still have the observations. For example, you may have the observation, and right now we assume normal. Okay, and you can have the possible value, maybe through some way you find it. Okay, even you find it, but we want to check it. How to check it? In fact, we use this statistic. How to have a statistic? Sample mean, sample variance. All right, and use this way. Something like this one should follow t distribution, right? And this one, actually, maybe you have some way to have the value. So sample mean minus the obtained value, obtained mean, and over square root of sample variance over sample size. And this is the task. And this one, we will follow t-distribution, so we call t-test. If you have the t-statistic, we simply have the absolute value. All right, and you can look up something like you look up through the confidence interval, right? So that's why previously I let you know the procedure similar to the procedure of confidence interval, but not totally, just the table lookup. If you can have the table lookup, the statistic, absolute value of a statistic larger than the lookup value, that says the threshold, then we reject. Smaller than, then we accept. All right, so this is the test. I think you can check some story about this, but you can follow this one and this one through checking. It is okay to first serve as the test. And such a test, it is called the hypothesis test or t-test. All right, so similar to the procedure, maybe not all, but part of the procedure in the confidence interval. And you may have some threshold. Here it is called threshold with the threshold t sub n minus 1, 1 minus alpha over 2. Then you can have the decision to reject or to accept. Well, that is a way to have the hypothesis test. If we have the situation, something like that one, all right, and we use t. We use t-distribution. Right? And right now we have this one. If this is t, so this one and this one, and this region is called critical region. And the critical region, we have the name, level of test. For example, level of test equal to 0.9. Okay, and this one 0.9, in fact, equal to the original notation alpha, right? Using the confidence interval, value alpha actually is the probability for this one, probability to determine the critical region. Actually, it is called the label of the test. Well, this one actually equal to this alpha. Once you have the alpha, then you have the statistic. For example, right now, we have this example. If we have the data of the previous example 19, right? And example 19 that you have sample mean, sample variance, right? And maybe for some reason, someone have the arithmetic mean already. If you have as a mean, so you have this one. That says you have a T19 through the calculation. Okay, through the calculation. But this one through table lookup. Right? through table lookup, and you can have the result. The statistic here greater than the threshold, so we reject. All right, so this is a way to have the testing. Such a testing, it is called the hypothesis test, and that's it. Well, maybe you have a question, why we want to have the test? Perhaps in chapter 6, you may have the procedure, and through some specific way, you can have the estimation of the mean. Once you have the estimation of the mean, and then you want to check, is it okay to accept that value? For example, the value here. So you can try the hypothesis test. Well, to try hypothesis test, we still follow the table lookup using T. And for T, right now, we have alpha directly. And you have alpha, then you use 1 minus alpha to the same as the way to check the confidence interval threshold, or that T. All right, so this is the hypothesis test if you want to check to accept or to reject. And actually, I just let you know the procedure. And for the further reason, maybe you need to look up, and after lookup, you can know exactly. But at least I let you know the procedure to perform the hypothesis test. Well, in chapter 6, we may apply these. So in chapter 4 here, we let you know we have these. All right, so about hypothesis test here, is it okay? Well, I assume okay. So let me continue. In fact, the remaining material perhaps will show you the large number, law of a large number, and some reminder. Here we have danger of replacing a probability distribution by its mean. You will have the direct image. Distribution replaced by mean? Of course, no. So that says it is not okay. So that's why we have a reminder about this. Well, what is the strong law of large numbers? It says if you have a really large sample size, right? With the large sample size, you can have a sample mean, right? And if you have the sample mean, the strong law of large numbers that you know, actually, this sample mean will approach true mean of the distribution. Of course, the distribution is unknown, right? That says this one. Sample mean will be arbitrarily close to. In fact, it will be close to the true mean. All right. How to close the true mean? The probability is 1. That says it's pretty sure. You use sample mean to approach the true mean. This one is really okay, and this one supported by the current law, strong law of large numbers, and that's it. All right, so you see, if we have the observation, the true mean here. The true mean here. And through different sample size, once you have a large enough sample size, you see around the true mean, right? And the strong law of a large number says if you have a large enough, and then you can approach the true mean properly. Okay, the final one, let's check the reminder. You see, is it okay to replace the input distribution by its mean? No. Right? No, it is not okay. All right, and actually the others the same, so I think nothing else. And here the same, that is have the possible example, so not okay. And the same. All right, so you can have the real story if we have the distribution. However, if you have a simple mean to replace the original one, is it okay? Not okay. And this example that you know, it is not okay at all. All right. So about the reminder, we may have some example, but I skip the details of this example. You can check it. At this, we just let you know, it is a reminder. Do not replace the distribution by its mean because they are different stories. So you cannot use story 1 to replace story 2. All right, so that's it. This is a reminder of the danger to replace the distribution by its mean. All right, so almost all. This is a discussion for chapter 4. Is it okay? About this chapter, we will have the reference homework, no need to handing, adjust daily practice. So I will let you have the solution maybe 1 week later or a few days later. All right. Once the reference homework are posted on the website. All right. So we will have this for your reference. I emphasize for your reference. That says no need to hang, but you can try to treat. It is a homework for you. So you can have the solution. I mean, you write it down for your own solutions. And you can compare your own solution to the solution released later. Okay. All right, so this is chapter 4. For chapter 4, we also have the extended discussion. But later for the extended discussion, I similarly have the initial result. And for the further practice, maybe I will left to you guys because we don't have enough time. But at least I try to go through some extended results slightly. All right, here I emphasize I go through slightly, but that the remaining part to you guys to practice further if you want to know more. And actually, I may assign some. It doesn't mean assign. I will select one of or some of the possible example from the supplements late to show later. And then I think if you want to know how to have the solution to some of the problem associated with the supplement, I think at least you need to check in detail. All right, so this is the formal content of chapter 4. If you guys don't have further question, then I want to show the results using the supplement. And you guys can check Moodle. Moodle that you have the supplement. And of course, I released yesterday. So right now you can have the supplement. Well, I just followed the order to have a discussion for you guys. I think you may have the right image. Here you have the slides, right? However, the slides somewhat different from the previous slides. Here we have more sentences. Am I right? So summarize, you have the compact and also a bit more detailed note. I mean, some note. So you can follow the slides. That says you can follow the note here to understand more. Right? If you can check it, I think you can understand it true. All right, so I just follow the description, all the sentence here, to check what we want to learn from the supplement. First of all, we need to have the transformation. What kind of transformation? This one. Transformation using function, right? So we want to map original variable, this one to this. For example, you can have the transformation using function g. Well, sometimes we may have the transformation, so that's why we want to have the discussion for mapping from x to y through function g. If you have this through function g, and then this one, it says, is y necessarily a random variable? If the answer is yes, then we are interested in the probability. Actually, this one is CDF. Even right now, we have the uppercase PDF. This is the CDF. Okay, and the task will use PDF, capital PDF here, but in fact, it is CDF. So we want to know CDF of Y and PDF of Y as well. Is it okay to have it? I think you guys can check all the description here. All right, all the description here. And all the possible G. It doesn't mean, oh, some of the possible G. Well, first of all, we just want to let you know if we are asked to let you have the given results or the given results, given, right? And we want to find CDF of Y and PDF of Y. So how to do? This example, I mean, at this I need to show some of the initial results for you. So that's why, I mean, I use this example to illustrate the initial result. What is the initial result? Find CDF first, then obtain PDF. Well, is it true? Here, look at this. Look at this. Fine. CDF. Okay, so anyone you let me have, I just follow. So you have this, right? And here it assume. First of all, you can assume A is positive. If A is positive, we have this. If we have this, you have X. So of course we have the X to have the results, right? Once you have the result, you can have this one through differentiation. Okay, so this is first result. And you can check this part. A is negative. A is negative. How to have this using 1 minus, right? Okay, and the same, you can have the differentiation to have the result, PDF. And put the two results together. So we have the conclusion. All right, so that's it. This is the first procedure. Find CDF first, then obtain PDF. For finding CDF, I think you just follow the concept here to express the equation in terms of y. Of course, initially, right? And then read the right so that the probability can be expressed in terms of x. Once you have the probability in terms of x, it will be possible to be expressed by the CDF of x. Once you have it through differentiation, I think you can find the PDF of random variable y. Okay, that's it. This is example 1. Is it okay? I think you guys check this for 3 minutes. And 3 minutes later, then I just let it check the next example. And I do not let it have many time, but at least, I mean, much time, but at least I ask you think about what we have for this example. Okay, look at this. If you have any question, you just let me know. Okay. Or otherwise, you can continue to check the procedure. Find CDF first, and then you can obtain the PDF. All right, so up to now, any question for this? If so far so good, I think you can try the second example. For the second example, I do not check in detail, but let you check the pages associated with this example. So first of all, find CDF, right? And once we have this, how to express this one? This one, then we have this. And then what it means. Lower than, so it says, fall in between the interval. So we may have the interval in terms of x. Right? And in terms of x, this one, it is square root of y minus square root of y. Once you have this, then you can have the difference. Right? Difference in terms of x. And by direct differentiation, you can have these. Right? So first of all, this one, CDF, and then PDF. All right, so I think the same. And I do not go through in detail, but just let you know the same. It says express CDF of Y in terms of CDF of X. After that, you can have a PDF of Y in terms of X. How to do? By applying the direct differentiation. Then you will have the results here. Okay, so this is a second example. Follow the same principle. Am I right? Okay, so maybe you can have some further discussion. So here you have the further discussion. I do not check in detail, but you can try. All right, and this one try to link this way, normal. Okay, normal to chi-square. Just for your reference. Likewise, you can check this example. And right now, I skip it. Same, you can try this example. The same, I skip it. And up to now, we have the concept, the right CDF first, and then you can have a PDF. That's it. And this one, we want to have a formula. And how to have the formula? You just want to that you have the observation. Here, this one observation in terms of X. And this one observation in terms of Y. And right now, we want to derive results for Y. So we can have the observation interval Y. But for Y, actually, you may have multiple X, right? If you have multiple X, you can use the something like the theorem of partition. So here you can go through the results here. This is the result theorem of total probability. And you can use a proper partition. Okay, once you have a proper partition, to have the three sets. The three sets allow you to have this formula. Okay, and we consider the difference positive or negative, but actually you will have the results, this one, right? And finally, you will have the results. For this one, I have the summary for this. Sorry, this one should be dy here. Okay, maybe we can skip. Well, to have this. If we have a dx, maybe I use dxi directly. Well, I forget one thing. So here I emphasize we still have this. Absolute value of dxi. And here, if you want to ensure, you can have a dxi. Okay. For this, what that means, I have the interpretation. Probability observed. by y, and this one probability observed by x. Well, if you have one event, but the event you can have the observation through y, or the observation through x. Do you think the two probability will be different? Actually, no. It should be the same, right? For the current observation, you see, this one, we have the interval dy simply, but for this, you have dxi. And I don't know if we have the possible cases like this. You will have a probability in terms of y by multiply dy. And here the same probability f of xi multiply dxi. But why we need to have the absolute value? You may have positive, negative, positive. So here, okay, positive, but this one negative. So that's why we need to have the absolute value for dx sub I. Okay, so if you know that one, then you will have the formula. Okay, once you have the formula, rearrange it. Y equal to this. Or maybe y equal to this one. Right? Summation, but finally you have the absolute value. All right, so I think you can check all the details to know why we have the formula. And later, I just select one of the examples to show you the application of the formula. But before we check the application of the formula, let us have a class break, take a rest first. All right, maybe someone like, but at least we will have that formula. I stop at this page, and later you can check the formula. And after the cross break, we will continue to let you know how to have the application of the formula. All right, up to now, is it okay? If no question, let us take a break for 5 minutes. That's it. Take a rest.